So, good afternoon, everybody. I will start today the chapter about fertility. But just before I started, it's just good to remind ourselves that next class is the exam 2. And exam 2 will cover the topics that we discussed in class from day 9 until whatever part that we finish today on day 15th in this chapter about fertility. So we're behind schedule, as I would expect. And so just some of these chapters here towards the end, we might not cover them, but the material will be available online. And the specific place where we started on day 9, you can just go to the YouTube channel and then fall 2021, watch here on day 9. So day 9, I was still on the topic about population change in the United States. So it goes back a little bit here to population change in the United States, and then goes until fertility that we will cover today, okay? For the fertility topic, there is this zipped file here. When you uncompress it, you're going to see 2 Excel files that I will discuss in class that shows how to estimate a series of fertility rates, fertility indicators. I have a simple file using data from Brazil and a more in-depth file indicating several different fertility indicators using data for the US. And a mix of readings, in this case, a short article showing how the fertility of Hispanic women in the US has been declining and getting closer to the fertility of non-Hispanic white women in the US. And if I find any other extra readings, I will just add into this compressed file here. And the lecture has been there already for a while. And exam, it's gonna open on Thursday at 8 a.m. on Canvas and close at 8 p.m. Once you open it, you have 1 hour and 15 minutes to answer it. Same style of 40 questions, 0.5 points per question, 20 points in total. Do not don't open so close to 8 p.m. because if you open it at 7 p.m. on Thursday, it's gonna close at 8. So you're gonna lose 15 minutes that you would have if you open it earlier, okay? So just starting down here on the chapter about fertility. Any questions about the exam? Anything? All good? Sorry? I cannot hear you. You don't have to come to class on Thursday. You can answer the exam from any place that has an internet connection, and you answer it on Canvas. And it can be between any time between 8 a.m. and 8 p.m. this coming Thursday, okay? As it was on exam 1. This chapter about fertility, it's subdivided, I guess, the textbook. In the first introduction, talking about some conceptualization and measurement of fertility, explaining some major fertility rates and indicators that we have. And then we go into a more theoretical part of fertility studies, kind of like thinking, okay, we saw some theories of fertility from the chapter on theories of demography. And how exactly do we test those theories? So this framework for predicting fertility tries to link previous knowledge that we have from fertility through this theoretical framework using what is called the approximate determinants of fertility, and then analyze data to test our hypothesis. And then I'm going to show some overall world fertility trends and patterns, and then focus in the US and showing specific data for adolescent fertility non-marital fertility and childlessness, a lot of women not having children at all for voluntary reasons. And I also talk about male fertility, which is a topic that's not usually discussed a lot, because fertility information, we usually get it from women. When we get how many children people had, that question is addressed to women. But because of this increase in men being part of raising the children and being more part of these activities, studies on male fertility have been increasing these last years. And we're going to talk about that towards the end of this chapter. So intercourse, having sex, conception, contraception, and fertility, having children, are influenced by cultural and social factors, right? And all these factors, we try to understand what are the factors that are driving the fertility rates. Is it related to frequency of intercourse? Is it related to people getting married earlier? Is it related to people getting married older? Is it related to that specific population not having access to contraceptive methods? Or is it related to that population having access to contraceptive methods? So these are all different questions, different studies that we can do about fertility. And as I mentioned before, when I first showed you the Alexis diagram in the first lectures of this course, we can do different ways of analysis. If we get data from a specific time point, from a specific population, trying to understand what are the fertility levels in that population, and I want to know what are the characteristics of women who are having more or less children, and I have information for a specific time, for a specific period, I can do a cross-sectional analysis, right? It's based on a specific point in time. And remember the Alexis diagram. The Alexis diagram, the horizontal axis we have year, the vertical axis we have age. And as we progress in time, people get older, right? If we have information from one specific time point, we have 1 year here in the horizontal axis, and we are getting information about people of different ages. In this case here, we would get information about women and them having children, history of pregnancy, and so on. It's a period analysis. It's called cross-sectional because we are crossing through all these different cohorts of women that we have here. Cohorts of women who were born in different years. If I do follow women over time, and I try to see changes in their fertility, and then I can compare the fertility of women who were born 10 years ago, 20 years ago, 30 years ago, not 10 years ago, but 20 years ago, 30 years ago, or 40 years ago, then I can compare these different cohorts. I'm doing a cohort analysis, and I'm trying to understand the fertility patterns of this group of people who were born around the same time and probably will have children around the same ages, around the same years. So around the ages of 15 to 49, they will all be around 15 and 49, the same time point. Cohort analyses are really useful to see how fertility is changing within a specific cohort, but also to compare women that were born in different years. But it's more expensive because we have to follow this group of people over time. If you have period data, I can analyze people with all different ages and understand their fertility patterns, but then I get limited because I don't see as much variation over time. I can do a micro-analysis in which I try to understand what are the individual characteristics that make some women being more likely to have children or not. Or I can do some macro analysis and where I get more aggregated level data and try to understand how that contextual, those contextual characteristics of the population where women live make them be more likely to have children or not. If I live in a more developed country, there is more urbanization, more economic development. It's more expensive to have children. People live in urban areas, that's more expensive to provide health services, to provide education to children, to provide food and shelter. Women will start to have less children, or families will start to have less children, right? And if I live in a more rural area, that I don't have access to any contraceptives, and actually having children, they can help me working in the rural activities, as it is the case still in some less developed countries, then fertility will tend to increase. In that case, I'm analyzing the aggregated level factors in their influences on fertility. So I'm doing a macro analysis. And what we're going to be talking here is exactly that. I mean, we have trends in fertility. We just first measure fertility. After we measure fertility, why we see those results? What explain those variations over time? What explain that specific groups have more children than others? And then comes this quest of trying to understand what are the reasons behind changes in fertility. That can be both explanations at the individual level or more at the aggregated level. Fertility is the actual production of male and female birth. So the word, whenever you see an indicator or the fertility rate, the numerator of that indicator is counting both male and female births. When you have an indicator that has the word reproduction on the name, like a reproduction rate, the numerator is going to count only daughters, only female births, right? So fertility rates are related to overall number of male and female births, reproduction, female births. And I'm going to talk a little bit more about the denominator as well. There is some variations in the denominator that I will talk when I show you the rate, the different indicators in the next slides. Fecundity is the biological capability of producing live birth. So there is not a real indicator that we would say, oh, that's the likelihood that women will have children in this population based on their biological characteristics. So but it's just good to understand that demographers here, we are focused more on fertility, the actual children being born, not fecundity, whether women can have babies or not. Usually, the childbearing years, the standard in demography, we consider being between 15 and 49 years of age for women. These are the main ages when women are able to give birth. Sometimes the age group can be even shortened to 15 to 44, especially in developed countries, when women do postpone the age in which they have children, but they don't postpone too much, right? So they postpone maybe from the early 20s to late 20s, early 30s, but then they have children in a shorter period of time. Some other terms that we actually mentioned them even before in the course: fertility, actual production of birth; infertility is childlessness, like so women not having children, either for voluntary or involuntary reasons; fecundity, the biological ability to reproduce, and there are different levels of fecundity, like subfecund people could be definitively sterile, probably sterile, semifecund, and fecundity indeterminate, when we don't have much information about a fecundity of a specific woman, for example. Infecundity is completely impossibility for biological reasons of women not having children. And so in that case, and it's related to more to biology, And the infecundity doesn't vary as much through populations if you have enough or good health standards for the population when women are growing up and so on. So again, usually we focus more in demographic studies on the actual production of birth, not much on biological reasons. Menarche is the beginning of the female reproductive period, the first menstrual flow. It marks when they are likely to start the biological ability to have children until the menopause, the end of reproductive period, termination of menstruation. So those ages, if a specific population as a whole has been shortened or widened, the ages in which women have menarche and menopause might affect fertility. And postpartum, it's an important term for us here. It's pretty much right after women have children, right after pregnancy, they will breastfeed their babies. So that period in which they are breastfeeding their babies, they are not likely to have order to get pregnant again while they are breastfeeding their kids. So if I have a specific population that gives women maternity leave for several months or even years, and they have the possibility of breastfeed their babies for a longer period of time, they will have this period in which they will not be likely to get pregnant again, even if they are having intercourse with their partners. On the other hand, if you have populations that don't provide long maternity leave, and then women start to feed their babies with a bottle of milk or formula, then they start to be again at the risk or chance of getting pregnant again, although they might have gotten the children not long ago, okay? So the postpartum period can be determined by cultural reasons of how a society is organized. So that is an important information for us because that affects the levels of fertility and is culturally constructed, is socially constructed, right? Whether women have more maternity leave or not, and whether in some societies, women are expected to breastfeed their children for a longer period of time. The first indicator that I'm going to show here is simple one, the crude birth rate. Oh, you talked about fertility and reproduction before. Now you're talking about birth rate. So whenever we say birth rate, the numerator, as in the fertility rate, does include all children here. Boys and girls being born in a specific year, right? But the denominator of a birth rate includes the whole population of that specific place, including men, not only women, right? So the crude birth rate, we get the overall number of births of boys and girls that happened in a specific year, in a specific population, and we divide by the size of the population in that specific country or in that specific state or in that specific location. And the denominator here also includes men. So here, baby boys, baby girls, and here the whole population, including women and men. So crude birth rate is simple as it is, because this number is declining a lot over time, we multiply it by 1,000, right? So we have numbers that don't have so many decimal cases, are a little easier to read. So this is data based on projections from the UN, from one of those websites that I showed you in the last class. So the crude birth rate declining from around 24 per thousand in the 1950s, and is expected, now it's around a little above 12 right now, and it's expected to be a little bit below 12 per 1,000 people. How do we interpret this? Using data from 1950 to 1955, in the US, there were around 24 births of baby boys and baby girls combined for every 1,000 people in the US at that time. 1,000 people, including women and men. And this number is expected to increase to a little below 12 per 1,000 population in the coming decades. The next one is the general fertility rate. So we change now from birth rate to fertility rate. The numerator, because it's fertility, as I said before, includes both baby boys and baby girls being born, number of births in a specific year in a specific population. But the denominator is different now. The denominator is not the population as a whole. It's only the female population between 15 and 49 years of age. And in the same way as the crude birth rate, we multiply it by 1,000, because otherwise this number would be really small. In some developing countries, you might have the number of children being born in a specific number of babies being born in a specific year, in a specific developing country, but you might not have the information of the female population. It might be a country that doesn't have that estimate, might have just the estimate of the overall population. In that case, you can still estimate what we saw before, the crude birth rate. But you cannot estimate this one here, but you can do an approximation. The general fertility rate would be the crude birth rate that we saw before, multiplied by 4.5, if data for the crude birth rate are the only ones available. If we do not have information about the size of the female population between 15 and 49 years of age for that specific place in that specific year. And these are some results for the US from 1920 to 2013. The blue line is the number of births experienced over time, and the left vertical axis is in the scale of medians, showing that it increased exactly after World War II, during the baby boom, declined again, and then it has been increasing with like some variations up to more recent years. And the rate here of the general fertility rate is per 1,000. So here, the right vertical axis gives the information of around 120 babies being born back in 1920 for every 1,000 women between the ages of 15 and 44. And that declined and then increased during the baby boom, and now it has been more stable over time. So it's interesting how these two sets of information here, they complement each other. If you just look at the number of babies, you might look, oh, we are having an increase in fertility. Not necessarily, because this is just the numerator of the formula. If you get the numerator of the formula and divide by the denominator, which comprises women between the ages of 15 and 44, the rate actually has been kind of stable over time, around a little over 60 babies per 1,000 women between those age groups, okay? But this rate is still, it's more informative than the crude birth rate, because the general fertility rate takes into account actually women who are the ones the ones who are giving birth. So it's not taking into account men. And these surveys, they collect information about fertility, usually for women. But let's say that, for example, a country has a huge proportion of women, a bigger proportion of women in older ages, and not as many women between the ages of 20 and 35, where the fertility rates are higher. So if I have a country that has older women compared to the other, that is not controlled with the general fertility rate because we are putting all these women together. So a way to kind of understand the different chances of having children among women of different ages within 15 and 49 years of age, we have to estimate the age-specific fertility rates, with the idea that women between 15 to 29, they have different chances of having children than the ones between 20 to 24. 2024 are more likely to have children than the ones between 15 and 19. And then it increases, and in some countries already starts to decrease here, and then decreases even more at older ages. So a way to try to capture these variations is to estimate these fertility rates, and just to be specific, birth rates of women are fertility rates according to the ages of women. And the usually standard that we do is the same overall childbearing years between 15 and 49. And we subdivide them into the 7 5-year age groups, 15 to 19, 20 to 24, and so on. Sometimes we can have the 35 single year groups being used between 15 and 49, but this information here tends to oscillate a lot. Remember that issue that we said, the preference for digits, when people report the ages and they usually report having an age that ends with a 0 or 5. If I have a country that has problems with that information, then estimating single year rates would not be reliable. So the common standard is to group it by these 5-year age groups. And how do we estimate the age-specific fertility rates, the ASFRs? We divide the number of births of women in each one of these age groups divided by the number of women in each one of these age groups. How do we symbolize the age groups? So here, that's what these symbols they mean here. The ASFR XN means that I will calculate the age-specific fertility rate for women who are in an age group that starts from X and goes until X plus N, right? So how I would symbolize the group from 15 to 19, I would write ASFR 15, 5, because the 5 includes the age 15, right? So it'll be 15, 16, 17, 18, 19. And these terms here might not be intuitive when we first see them, but that's the standard in demography, even for other rates in mortality and also in migration. So here I'm calculating the age-specific fertility rate from an age group that starts on age X and has the width of N, goes from X until X plus N. Get the number of babies born to women in that specific age group, for example, here, 15 to 19, and divide the number of births of women that were 15 to 19 in that country in that year, divided by the number of women with those ages. And the age-specific fertility rates can also be really small in number, so we usually multiply them by 1,000 as well. And the typical age curve of fertility is something that I already showed before when in the chapter about age and sex composition. I kind of showed that fertility, mortality, and migration, they vary by age and sex. And in fertility, I showed that typical curve of fertility rates by age. If we plot the age-specific fertility rates for the 7 age groups So I have the 7 age groups in the horizontal axis and the rates in the vertical axis. I will get usually this inverted U-shape graph, which is this slide here shows an example. Well, here's the age-specific fertility rates for Africa as a whole, and fertility for women in Africa between 1970 and 75, and then from 2005 to 2010. So this number here, it's multiplied by 1,000. So here, for a woman between 15 and 19 means that they had little less than 150 births for every 1,000 women between the ages of 15 and 19 in Africa back in 1970 and 75. And overall, the fertility has been declining over time when you compare the green and the purple lines. And you also see something else. You see this decline, but what else do you see there? See two other things. This decline, it's not so strong in younger ages and older ages because these are already low levels. The steepest declines you see exactly in the ages where the chances of having children are higher. 20 to 24, see this gap here is wider than here. This gap here is wider than in older ages. And moreover, what you start to see is that now women tend to start postponing the ages in which they have children. It's still in both years, in both periods, the highest rates of fertility are for women among 25 and 29. But this rate here is kind of like close to this one here, really close to 300, both of them. But this one here, it's actually bigger than this one if you compare the differences back in the 1970s. So with a simple graph, you start to see declines in fertility over time. The biggest declines among women that have exactly the highest chances of having children, and you start to see some signs of postponement in the age of having children. Women start to have children at older ages. In Europe, that's even more clear, the postponement. So you see, compare the same period, the 1970s and the 2000s, you see a decline in fertility, but this decline you see more in younger ages, not as much in older ages, because at older ages, women in those in Europe already have low fertility, so the room to decrease is smaller. And the highest decline is exactly among 2024 and 25 and 29, who are the groups that have the highest chances of having fertility, having babies. And we see here is more clear than what we saw in Africa. 2024, the rate was higher than among women between 25 and 29. But then as women start to postpone their having children to older ages, 25 and 29 in 30, 34 have age-specific fertility rates higher than 2024. So you change the level and the pattern, right? Now all the groups are more likely to have children than women between 20 to 24. But this is a lot of data, right? I mean, it's for every year, for every country, you have these 7 indicators for each one of the 7 age groups here. Is there a way to summarize the age-specific fertility rates into one single indicator? And that's the total fertility rate. The total fertility rate is the one that we usually hear, is the most popular measure of fertility. We usually hear, oh, what's the average number of children that women are having in a specific country based on data from a specific year? That's the total fertility rate. It's mostly cross-sectional. We usually get information for a specific year, but we could also follow women over time and do a cohort analysis. So how exactly, what's the correct definition of total fertility rate? It's the number of births that a hypothetical group of 1,000 women would produce during their reproductive years. So wait, let's go back to the previous graph. This woman here, who are 20 to 24 in 2005 and 2010, these are their chances to have children. 5 years later, 2010 to 2015, they will be here. This woman, 5 years later, they will be here. But the chance of this real woman 5 years later to have children is not going to be the same as these ones here. These ones are for women 20, 25, 29, between 2005 and 2010. This woman here, when they reach this age group, it's going to be another year. It's going to be the year 2010, 2015. And the fertility rate is going to be different. It's not going to be the same. So when we get this group of rates here, let's get the purple ones here. We get these rates here for 2005 and 2010. And we group them with the procedure that I'm going to show in the next slide. You are not talking about real women. You are talking about this hypothetical group of women. Let's get this hypothetical group of women and expose them to these age-specific fertility rates. If they were exposed to these age-specific fertility rates between the ages of 15 and 49, how many children on average they would have? Remember that I talk about this hypothetical measures. The same thing about the life expectancy at birth. The life expectancy at birth is the same idea. We get mortality rates by age groups, and we expose a group of people to these mortality rates, and we're going to say how many years on average we expect them to live, to survive. Infertility is the same thing. What I'm saying is, if I get a group of women exposed to those age-specific fertility rates, how many children they would have on average? Because this woman here who are 15 to 19 have this age-specific fertility rate in 2005 and 10. 5 years later, in 2010, 2015, that's not going to be their fertility rate. It's going to be a different one, right? So that's why when we combine cross-sectional data to estimate the total fertility rate, we have to understand it as a measure for this hypothetical group. How exactly do you measure? It's simple. You just add all these the age-specific fertility rates that you estimated before, but the age-specific fertility rates that you estimated before divided by the woman in each one of the age groups. And each one of the age groups have the interval equals to 5. So you multiply each one of, you sum them all, and then you multiply by 5, which is usually the width of the age group. I can be symbolized by I or N in different notations. Usually TFR is divided by 1,000 if the previous age-specific fertility rate was multiplied by 1,000. If you multiply this one by 1,000 here, then you add them all, multiply by 5, and divide by 1,000. But if you have not done this multiplication, just add all the age-specific fertility rates and multiply by the width of the age group, which is usually 5. Okay? And that's an example of variation of total fertility rates over time between 1911 and 2011. And we clearly see these changes in levels, like with the Great Depression in the 30s, less opportunities for work, people start postponing the ages in which they will marry, have children because they don't have a stable life and so on. Fertility declines. In the 50s and 60s, it increased, and then you experience more economic crisis, fertility declines, but then you start to live in a world that it's more expensive to have children, and people will decide to have fewer children. So the level of fertility continues low, around 2 children per woman. But even now, more recently with the Great Recession, we also saw some declines. And now, because of the pandemic, because the pandemic is related to, it had huge impacts on unemployment rates, a lot of people losing their jobs and so on, that it's also expected to have influences on the level of fertility. Fertility is expected to decline as a result of the pandemic. So the pandemic affects both mortality and fertility, and also migration because of all closing the borders, lockdown policies, and not letting people from other countries move in or come to the US, for example, if they're not vaccinated, and for a while, they were not vaccinated. So the pandemic is affecting everything: mortality, fertility, and migration. I just want to show you, I mean, these analyses are coming out now, so it's all really preliminary. This is an article, a news article, just showing how, emphasizing that American fertility rate has been declining. And this article is just now from March 26th, and emphasizing that the fertility in the US was already low. It reached around, it's hard to see my mouse here, but on the left here, 1.7 births per woman in 2019, but now is expected to decrease even more. And this portion here, it is apparently, the pandemic is apparently causing baby bust. Researchers estimate that the pandemic will result in 300,000 to 500,000 fewer babies born in the US. Lockdowns and fear kept young people from meeting and marrying. I think that's not actually, my hypothesis is that's not the most important factor. My hypothesis is economic hardship discouraged many young couples from having kids. Among the 33 states that had annual data available, there were about 95,000 fewer births in 2020 compared with the year prior, a decline of roughly 4.4%. Meanwhile, the Guttmacher Institute survey showed that as a result of the pandemic, 34% of American women have either put off plans to have children or reduced the number they expect to have throughout their lives, right? So all this uncertainty, like people losing jobs, even now that the economy is going back to track and we have support from the government, from these monthly payments for certain families that have children and don't gain and have income below certain levels, even with that support and jobs coming back, people will not decide to have children from 1 month to the other. They will try to wait to see how the situation goes on. But this is just to show that the same things that we saw in the past related to economic oscillations is expected to influence fertility, and it's influencing fertility right now and in these coming years, okay? To estimate the total fertility rate, you have to have really refined information, right? You have to have the number of children being born per age of the mother, at least the age group of the mother, and the number of women in each one of these age groups. If we don't have that at all, if we just have the number of births and the overall population, let's say they don't have even the population of women, just population as a whole, then I can get the crude birth rate, multiply by 4.5 as I did before, and multiply again by 30 as an approximation for the TFR. Let's see that I do have the number of births and the population of women between 15 and 49, but I don't have the information by 5-year age groups. I can get the general fertility rate and multiply by 30 if only data for overall number of babies and overall number of women are given to us if we cannot break it by the 5-year age groups. Usually, the total fertility rates, we prefer to analyze data for specific years, for specific periods, instead of cohort data, not only because it's cheaper, because it gives us information of what's going on in a specific time in a specific population, right? Usually for policymakers tends to be more informative, but cohort total fertility rates can be also an interesting way to understand fluctuations, postponement in fertility among specific groups of women. When we talk about fertility, demographers, they also talk about what is known as natural fertility. Natural fertility would be the number of children that women would have on average if they marry early, they were having intercourse with their partners, they were not using any form of contraception, and the family had good health and good nutrition, because health and nutrition affects fertility, right? And based on studies by Henry and Colin Russell, they expected the natural fertility to be around 6 to 7 live births per woman on average. If people marrying early, intercourse, no contraception, that would be the expected number of children that women would have. So that's a level of reproduction, the absence of deliberate fertility control. And overall, 25% of the completed fertility is due to genetics. So in this case, fertility and infecundability, fecundity and infecundability, they do affect fertility because 25% of fertility is due to genetics. So I take back a little bit what I said before. And that's the same proportion as we have in mortality. But a lot of the variations that we see in fertility are related to socioeconomic, cultural, demographic reasons, not specifically to biology. But then it's interesting to say that here in the US and also in portions of Canada, the Hutterites, this ethno-religious group of people formed in the early 16th century, data from 1930s show that women from this group had around 11 children throughout their reproductive ages. And what researchers saw was that this group of women, they had early age at marriage, good diet, good medical care, regularly engage in intercourse without contraception or abortion or anything form of deliberate fertility control. And nowadays, almost all live in South Dakota, North Dakota, Montana, and Western Canada. But this data from them from the 1930s is taken as the standard of natural fertility among demographers. So we kind of see this woman, good diet, marrying early, having sex, no protection, 11 children per woman. Other countries are having less. What explains these differentials? And that's where we try to come up with the answers, right? Of what are the differentials? What's explaining these differences in fertility levels across countries? The non-biological differences, the non-genetic differences. And you could say, oh, but in some developing countries, you still have early age at marriage and people engage in intercourse without contraception. But in a lot of these developing countries nowadays, they don't reach 11 children per woman because they don't have good diet, they don't have good medical care, right? That specific group reached such a high level because all these factors combine together. And just to show you in data, this is when we compare the age-specific fertility rates of the Hutterites with age-specific fertility rates in Mexico in 2010, US, dash line in 2010, and Canada, the gray line, also in 2010. As we talked before, the total fertility rate among the Hittites, 11 children per woman. In Mexico that year, 2.2, US 2.0, Canada 1.7. And the age-specific fertility rates, they here multiplied by 1,000, they are showing below each one of them. So here, this number, 250 births for every 1,000 women between 15 and 19 years of age for this group, for the Hittites. In Mexico, 63 births for every 1,000 Mexican women between the ages of 15 and 19, right? But this gap here, this differential here between natural fertility and the fertility observed in these other populations, what explains it? What are the reasons? So these are some of the questions that we start to ask. And when you compare the rates from Mexico, Canada, and the US, you also see some differences in patterns. In Mexico, higher rates in younger ages. In the US, lower rates in these younger ages and a little higher between the ages of 30 to 34. So you start to see, compared to Mexico, women in the US having children at older ages with higher chances, between 30 to 34 and 35 to 39. And in Canada, even lower chances of having children at younger ages, and older ages, they have even higher chances of having children compared to Mexico and the US, right? What explains that is exactly all these different factors: economic development, access to contraception, education. Women start to invest on their education, invest on getting a job before having children, before getting married. Oh, and by the way, that article that I just showed it to you here, I will just add it to their website. I will add it together with that other compressed file that I have there for extra readings within the fertility day in the website, okay? Another measure of related to reproduction, and now we change the words from fertility to reproduction. It is calculated in a similar way as the total fertility rate, but the numerator only includes female births, not male births. So we just have female babies divided by women, still in those 5-year age groups. So the notation here, we added this F to say that we are talking about female births per woman in age group X to X plus N. And N being the width of the interval, which also we multiply here at the end when we add all these age-specific fertility rates related to female birth only. That's a lot of detailed information that we have to have in order to estimate the gross reproduction rate, because the gross reproduction rate, we have to have information about each one of the subgroups, and the numerator is only female births. So if we don't have that information available, you can take the total fertility rate and get the number of female births divided by the number of births to get an approximation of the gross reproduction rate. And this number here of 0.488 is based on the sex ratio at birth of most countries. So this number here is not a magical number. We are getting the overall number of female births as a proportion of the total number of births. The usual sex ratio at birth in most countries, countries that don't have a preference for boys, is around 105. What does it mean? 105 boys being born for every 100 girls. So how do you calculate the proportion of female births? The proportion of female births equals 1 minus the proportion of male births. So it's 1 minus, what is the proportion of male births? It's 105 boys for every 100 girls. So we have 105 boys for every 205 overall babies being born. Boys and girls. Boys divided by boys and girls, we have the proportion of male births, which is around 51%. So the proportion of female births will be around 49% or 0.488. If for a specific country, the sex ratio at birth is not equal to 105, so we should just do this calculation here by putting the correct sex ratio at birth both here and here, and calculate the number that you could use here to approximate to the gross reproduction rate, right? You can go further. You can go to this indicator called net reproduction rate. The net reproduction rate adds another component, adds the possibility that women, they have chances of having children, but they also have chances of dying. And they have chances of dying before they reach 15 years of age, before they reach 20, before they reach 25, until before they reach 49. So they have the chances of having babies, but they also have the chance of dying. And by having the chance of dying, then they will not have babies anymore. So we have to discount for the mortality factor. So the net reproduction rate considers the effect of mortality among mothers from the time of birth of their daughters. So for all between 15 and 49, we consider the chance of these mothers dying, so they would not have the chance of having babies, of course. And it's based on the concept of population replacement. And that's something that it's mentioned in that short article that I showed to you guys here, and I will talk about that a lot. What does it mean, fertility below the replacement level? Fertility below the replacement level means that a population is having children at lower levels, that the children will not replace previous generations, the generations of parents. So probably the population size will decline, right? Because people are having fewer children. If you're talking about fertility rates, we'd expect, a couple should produce 2 children to replace themselves, the couple, right? So when we die, then our 2 children will replace us in society as the new generation. But we also know that more boys are born on average than girls. And some of these babies will not reach reproductive ages. So we have to give a little discount or increase a little bit what we have in order for this new generation to replace us. So the total fertility equals to 2.1 is taken as the fertility, as that line that divides those places that have fertility below the replacement level or not. So countries that reach total fertility rates below 2.1, they are producing fewer children to replace the previous generations, the previous generations of parents. And already put in the 2.1, that gives a little more girls overall, and also takes into account the mortality factor, that some of these children, both boys and girls, might die before they reach reproductive ages. So wait. And one thing that we did, even before here with the gross reproduction rate, was to focus only on daughters. Why did I focus only on daughters, only on female births? Because usually, if we are trying to see information of how big a generation is going to be in the future, it's good to see how many female births we're going to have, because they are the ones who will give birth to the new children. So whenever we are talking about what we expect to a population to replace the other or not, we use this reproduction, these rates that are related to female births, the reproduction concept. So even before here, when I was talking about the gross reproduction rate, I was saying it's based on the concept of population replacement. The same thing for the net reproduction rate, based on the concept of population replacement, with the idea that we are focusing on women, on female births, because they will be the one giving birth in the future. And we want to know if they will have enough births to replace themselves, their generation. The previous gross reproduction rate did take into account only female births and did take into account the width of the interval. But now the net reproduction rate adds something else, adds this mortality factor. This mortality factor here, it's going to be a little hard for you guys to understand it. We're going to understand it better when we go into the chapter about mortality and we talk about life tables. That's where this information is going to come from. But at least conceptually, it's important for you to understand. Women are having female births, and women will be replaced by their daughters to have births in the future. But these women might not survive up to 49 years of age, so they will have less chance of having daughters. So these women, we have to subtract or account for the chance of this woman dying. And that's this portion of the formula. The big LXN is the total number of person years lived in an age group overall. If I have an age group, that 5-year age group, from X to X plus N, let's say from 15 to 19. If I have 1,000 women with 15 years of age, and all these 1,000 women, they survive to age 20. How many years did they all live together between 15 and 19? I have 1,000 women, 15 years of age. They survive until the age of 20, all of them. There is no mortality in my example. How many years in total did they all live together? They lived 1,000 years when they were 15, another 1,016, another 1,017, another 1,018, another 1,019. This measure is called by demographers person years. In this case, if nobody had died, we would have 5,000 person years lived. If we had 1,000 women at the beginning of the interval and multiply by 5, we are saying 5,000 divided by 5,000, everybody survived. 1. Proportion equals to 1 means 100%, right? So this indicator here is the proportion of people who survive from age 0 to the midpoint of each of the 7 age intervals. So for each one of the age groups that we have, between 15 and 49, all those 7 age groups, we kind of measure what's the chance of women surviving from age 0 here, up to the midpoint of that specific age group. And this little L0 is the number of people being born at age 0. And in this example that I gave it to you, I had 1,000 people being born, 1,000. All of them reach until age 20. So between 15 and 19, 5,000 person years divided by 5 times 1,000, 1. That was the exercise. If we calculate that, we estimate the number of daughters that women are expected to have based on the age-specific fertility rates. of female births and considering the chance of women dying over time. If I don't have this detailed information about female births, but overall male and female births together, I do that same transformation as I did before, multiply the ASFR by 0.488. But I still need to have the mortality factor, right? And this mortality factor is just think about the idea. People are dying over time. I have to discount that some women are dying, they will not have children. And what's the proportion of them reaching the midpoint of the 15 to 19 year age group to reach the midpoint of the 20 to 24, the midpoint of 25 to 29. That's what we are doing here, right? We are doing this exercise for each one of these age groups. And a final measure is the mean length of a generation. The mean length of a generation is the mean age of mothers giving birth to live daughters is still related to reproduction, only female births, with the current age-specific fertility rates and take into account mortality. So we take into account the age-specific fertility rates, only count the female births. We do take into account mortality, proportion of people who survive from age 0 until the midpoint of each one of the 7 age intervals, the width of the age group, and the midpoint of each one of those age groups. We get this and we divide by the net reproduction rate, we get the mean length of a generation. This all seems abstract here, but then if you just go into the website, what I mentioned to you guys is that here you can download this compressed file that you uncompress, you're going to have these 2 Excel files. And that extra reading is not here yet in this compressed file. I would just add it there so you can download it as well. That short article about the effects of the pandemic on fertility rates in the US. And these 2, where's my mouse? I cannot see it. Here. So these 2 files, one for Brazil and one for the US. The Brazil is simple. It's just showing age-specific fertility rates. I got the female population for these years, not many years, only from 1994 to 2005, for the 7 5-year age groups. The number of women that were between 15 and 19 years of age in 1994, and so on. The total number of women each one of those years. And these are the number of children that women with those ages had. So women back in 1994 who were 15 to 19 years old, they had 490,716 babies. So if you get this number, 490,000, and divide by 7.9 million, we get the age-specific fertility rate for women in Brazil between 15 and 19 back in 1994. And that's this exercise here. This exercise here is pretty much just getting the previous 2 tabs of data, getting the cell in the birth, divided by the female population in that specific year, in that specific age group of women. These age-specific fertility rates here are not multiplied by 1,000. So I just add them all. I added them all here from cell B4 until B10 and multiply by 5, which is the width of the interval. And then I have that total fertility rate in Brazil was around 1.8, increased, and then it starts to decline again in more recent years. And I can put all these age-specific fertility rates in a graph format as well. this graph is pretty much getting this data from here. Of course, it's messy, but that's because we just have so many years there being analyzed. But it's just a way to show how we can analyze the age-specific fertility rates in a more simple way in graphs instead of this table that you just get dizzy with like so many numbers. But the total fertility rate summarizes those age-specific fertility rates for each one of those years. And then for the US, we have more refined information. We can estimate everything that we saw in these slides. We have the age group, the same as we saw for Brazil, the same 7-year, the 7 5-year age groups, breaking down this overall age group from 15 to 49 into the 7 groups. The midpoint, pretty much getting 15 plus 20 divided by 2, 15 plus 20 divided by 2, 20 plus 25 divided by 2. That's the midpoint of the age group that we're going to use later on. We're going to use later on with the mean length of a generation. The number, all these cells that are in yellow are raw data that I collected from other sources. And I collected this information from, I think from the Center of Disease Control and Prevention, CDC. And here I have the number of women in each one of these 5-year age groups, and the number of births to women in each one of these age groups. So we have a total of 73 million women in the US in 2012, and overall number of 3.9 babies being born to these women. The first estimation that we can do is really simple. Is the general fertility rate. What we do, we just sum column 4 and divide by the sum of column 3 and multiply by 1,000. So I just get the sum of this, divide by the sum of this, multiply by 1,000, which is the same as getting this, divided by this, multiply by 1,000. We have that overall, for every 1,000 women in the US in 2012, they had almost 54 babies being born that year for every 1,000 women. And if I want to take into account the chances of each one of the age groups, I first estimate the age-specific fertility rates that divides the births by the number of women, that symbolized here by the capital F. So I calculate this divided by this. I have each one of the age-specific fertility rates for each one of them. And I add them all and multiply by 5 to get the total fertility rate. So the total fertility rate, I just get, we are still having class. We are having a class here, finished at 2. Okay, now you're already interrupted. So this one here is, I'm adding this column and multiply by 5 because that's a 5-year age group. I have 5 years within each age group. And here I'm saying that if a hypothetical cohort of women experienced this age-specific fertility rates throughout their lives, they would have on average 1.88 children, right? Between the ages of, and women between the ages of 15 to 49. And then we go into the reproduction rates, the reproduction indicators. And for that, we have to get out of these total births here, how many of them are female births. See that all these numbers are below these numbers, because here I include baby boys. Here I just have baby girls. And another information that you have to get is information about mortality to estimate the net reproduction rate. A simple thing that we do first, just get the number of baby girls divided by the number of women in each one of the age groups It's here, female births, the BF divided by the capital F, each one of them, add them all, and multiply by 5. So if a hypothetical group of women were exposed to these chances here of having female births throughout their lives, they would have on average 0.917 daughters throughout their reproductive ages. So the exam, I will consider everything being done until the mean length of a generation. Although I didn't show here in the Excel file, I will show it to you next Tuesday. Show the net reproduction rate and the mean length of a generation. But it's pretty much, I'm applying those formulas that I showed you in the PowerPoint here in the Excel. Okay? So thank you. Have a great exam on Thursday, and I see you guys again on Tuesday.